Hello and welcome to another modern OpenGL video. In this tutorial, we're going to be looking at materials. So first and foremost, what is a material and why would you use it? In the real world, you have objects that are made out of, well, different materials. You have objects that are made out of metals, wood, plastic, that sort of stuff. And as a result, these materials, these objects, they react differently to light depending on what they're made out of. Generally speaking, something that's made out of metal will be shinier than something that's made out of wood. Wood generally isn't shiny, obviously, if you apply some sort of varnish to it, but again, that's would be a sort of an additional layer to the object. That's not wood anymore, it's wood with something on top of it that provides that sort of shine to it. And then you have sort of glossy materials, you have sort of more matte materials. Simply put, materials in OpenGL will allow us to create objects that react differently to light, and as a result create a more realistic and varied effect in our game or application. So that's what it is, and well, yeah, that's why you would use it, to get a more varied and realistic representation of the objects you are trying to create. Okay, let's get started. A few prerequisites. This is using the source code from the previous video, which was covering basic lighting. If you haven't got the code for that, feel free to check out that video. Plus, there'll be a link in the description to the GitHub source code page, which will have all the source code from every single video in this series. Another thing is, even though I'm doing it on Xcode on a Mac, it does not matter. Even though I'm using GFW, doesn't matter. Use whatever framework you want, GFW, SDL, SFML. We've got videos for all of them covering the setup process. Plus also, doesn't matter whether you're on Xcode or Mac or Windows or Linux or however, if you know how to build it and you set it up, you're all good to go. So this tutorial is cross-platform. The other thing I want to mention is these videos are based off the work of learnopengl.com and open.gl. So I've actually got an image here from learnopengl.com that they're using. Fantastic image to illustrate what we're doing. And also feel free, I would recommend checking out their pages because they got some great information. They go into really great depth of this code and just other code as well. So it's just a great way of enhancing the knowledge you already know. So as you can see, so something like emerald will be shinier than a green rubber object. Gold is obviously very shiny compared to something like a bronze object or a cyan plastic object. So what we're going to do is create, actually let me just run this application a second so you can see what we had last time. This is what we had, just this light that was going further and further away. You know what, I'm actually going to disable the light pause movement because that might sort of get in the way of what we're trying to demonstrate. Yeah, so what we had was just this general material applied. You had some, shading applied, which was Fong shading with a combination of ambient, which is a general sort of lighting. It was diffuse, which is sort of the object color. Like it depends on the angle of the the light. And he had specular, which was this sort of, let me try and get it right here. So you see that sort of shine on it, that's the specular, something that you'll see on an 8-ball. What we're going to do is make this cycle through various different materials. So first of all, you want to go to your lighting fragment shader. The vertex shader can stay the same. So in here, right at the top, what we're going to do is create a struct called material. Let me actually zoom in so it's easier to see. Struct called material, and put a semicolon here. In here, we're going to have 3 vector frees, which is going to be the ambient, the diffuse, the specular, and the shininess. So we can easily change the intensity of the specular. Vec free, ambient, vec free, diffuse, vec free, specular, float, shininess. Okay, now that is all good. We're going to create a struct for light. Actually, I want to put a capital for this material struct. So we got a light struct, and this is going to have a vec3 of position. It's going to have 3 more vec3s. I think you can guess what these are going to be. Ambient, not ambient. Vec3, diffuse. If you want to know a bit more about what ambient, diffuse, and specular are, feel free to check out the previous video, or feel free to go to learnopengl.com, open.gl, or a quick Google will provide a lot of information. So we're going to put vec3, specular, and now if we scroll down, what we can do is get rid of this color, because actually no, sorry, we still want that. The frag position, we want that. The normal, we still want that. We want the view position. We don't want the light pause because we have it within that struct here. We don't want this object color, and we don't want the light color as well, because again, we've got it all within our struct. So we want a view pause, need a uniform material. I'm just going to call it material, keep things simple. And we also want a uniform light. And now in our main, what we're going to do for the ambient, we can get rid of the ambient strength, and we can just do ambient equals light dot ambient times by material dot ambient. And for the diffuse, we are normalizing the normal, that's fine. For the light direction, we need to change this up a bit. So what we're going to be doing is, we still want a vector 3. We're going to get rid of that. We need to do reflect the negative of the light direction. And I'm doing this passing norm, and also we want to rename this to view. No, what am I doing? Sorry, my bad. I'm sort of skipping ahead to the specular stuff. So we got norm, we got the normalized norm, that's fine. We got the light direction. Actually, it was fine as it was. That was my bad. I was thinking of the next part. So this should actually be light dot position, because that code was from before. Light dot position minus frag pod, that's fine. For the diffuse float, we are doing max dot normal light direction 0.0. Happy with that. And for the final diffuse calculation, what we need to do is change this up slightly. We need to do light dot diffuse times by diff, which was calculated here as a float variable, times by material dot diffuse. We are factoring in material in every single part of our lighting, our shading, simply because that's what's important. That's the way our actual object will look, or that part of the object, because we have different materials applied. So specular, we can get rid of specular strength because we've got the upstairs, well, not stay, I mean in the code previous, not upstairs, sorry. View direction equals normalized view pause minus frag pause, that's fine. For the reflect direction, we got light direction, which was calculated here. Norm, we're just going to reuse it. For the specular, we can just do power max dot view direction, reflect direction 0.0. And for the shininess, we do material dot shininess. For the specular, we are changing this up slightly. We're going to do light dot specular times by spec dot material dot specular. And for the result, we need to do, we can actually get rid of the object color because we're factoring in the material every single time, so we don't need to do anything with that. And yeah, we're actually done now for Fragment Shader. If you go to the main CPP, and what you want to do is actually go straight to the while loop, because everything outside of that should be a-okay. And we could even comment this back in and see what it looks like. I haven't done that. Actually, we'll do that once we've got the code working. So let's just get the code all running first the way we want it. So for the lighting shader.use, we don't want an object color location. We don't want a light color location. We want a light pos location, but this needs to be changed to light.position because we updated a fragment shader, remember. For the view position location, view pos is fine. We can get rid of these two. And for the light pos location, light pos.x, y, and z is okay. The view position location, x, y, and z, again, is fine. And what we need to do is also set the light properties. So to do that, it is really simple. You do glm : vec3 light color. And what we're going to do is light color dot r equals sign. And this is where we're going to have some framework specific code. We're just going to be getting the GL, we're going to be using GLFW get time, which just gets the amount of time that passed since GLFW was initialized. There will be links in the description for the GLFW API guide for getting time, the SDL API guide, and the SFML API guide as well, so you can easily learn more about it and adapt it. Again, very easy to change. So if you've got this far, it'll be easy to change to SFML or SDL or anything else really for that matter. We're just going to do times 2.0f. You can modify these however you want, and I recommend doing that. That's a great way of learning. Try changing this one to a 1, a 5, see what happens. See if you can break it, see what are the boundaries of these limits. Again, that's always the best way of learning. This is 0.7f. And for this needs to be RGB. (1.3f). Okay, so now that we've set the light's properties, we need to actually do the diffuse color and the ambient color. So we're going to do GLM. Oh no, my bad, not in here. It should be 1.3. So we're going to do GLM vec3 diffuse color equals light color times by GLM vec3, and for this we're just gonna provide a value of 0.5, so this will just be 0.5, 0.5, and 0.5, and this vector 3, and this is just going to decrease the influence of the diffuse color. And we're going to do a GLM vec3 ambient color equals diffuse color times by GLM vec3. It's going to be 0.2f, and this is just a low influence. Again, modify these values and see what you come up with. Now what we need to do is GL uniform 3f GL get uniform location I'm going to do lighting shader program light.ambient. We're going to do ambient color .r. Probably best if I move the screen over slightly so you can see it a little better. I'm going to copy and paste this because I think you can guess what the next two parameters are going to be. R, G, and friggin' goddamn B. And what we need to do is just duplicate this line a couple of times. The GL get uniform location and the GL uniform free is going to stay the same. So I'm going to sort of just move my screen over here for these two more lines. We need to change this to diffuse. Change this to specular. And for this, you just change this to diffuse. Copy and paste it to save some time. But for this, we're just going to explicitly set some values. And I'm just going to put 1.0f, 1.0f, and 1.0f. Again, modify these values, always the best way for learning. I know I'm repeating that a lot, but it literally is always the best way. Now we're going to set the material properties. For that, we're going to do the ambient, the diffuse, the specular, and the shininess of the material. So you want to do GL uniform free F, GL get uniform location. You want to do lighting shader.program, comma, and the selector is material.ambient. The values, we're going to just put some explicit values. We're going to put 1.0 f, 0.5 f, and 0.31 f. Just copy and paste this. Need to change ambient to diffuse. Let's change. Honestly, we're going to leave that as it is. Oh shit, my bad. You were meant to say material.diffuse, not just diffuse. You need to change this to specular, material.specular, that is. And for the specular, we're going to put 0.5f, 0.5f, and 0.5f again. And then finally, we also need to set the shininess. So shininess, this is going to be 32.0f. Finally, there's something that it does not like. What does this not like? What's diff? Should be just one float value, because remember the shininess wasn't a vector or an array or anything like that. My bad, my bad indeed. For the view matrix, again the view matrix from the camera, that's fine, we're not going to be touching that. For the model, view, and projection location, not going to be touching that. For the uniform matrix, for the view and the projection, not going to be touching that. In terms of drawing the box, that's okay. Let's check out the lamp shader. The model, view, and projection location is fine. The uniform matrix for float values, that is okay. And translation, the scaling, the model location, I believe we are actually all ready to run this. So now let's run this, see what we get. It's going to be pretty interesting, to say the least. Okay, that's not work. Ooh. That was trying to do something. I wonder if there's some sort of error. Let's have a look. See if anything appeared in the debug console. No, nothing did. See, as you can see, he's trying to do something. It's almost like he's trying to breathe, but he just quite can't. Let's have a look at here. Material, ambient, diffuse, specular, shininess, that's fine. Position, ambient, diffuse, specular. Front position, normal, color, view, position, material, light. Honestly, it's all looking pretty solid to me so far. Light the ambient time and material the ambient. If there was some sort of spelling mistake in here, the console would have printed that really as an error. But let's just confirm. Light the position minus frag position. The diffuse calculation is max dot normal light direction. 0.0, diffuse, for light.diffuse times by diffuse times by material.diffuse, view direction normalized, view position minus frag position. Just going through this code, and honestly, it's looking pretty solid. I can't see any obvious mistakes in it. Again, I'm still looking, still seeing if there's anything that I can see that stands out as being wrong. Let's go to the main CPP. Must be something in here. Well, there pretty much has to be, because I don't remember it looking like that at all. So, because I'm positive that I haven't missed out some sort of line, well, before the while loop, and the normals won't have changed. So the question is, were there any sort of differences in here that haven't been updated? In all fairness, no, it looks pretty solid to me. So, but I'm just going to confirm all the values again. So we've got lighting, shader program, light.position, view pos. Definitely view pos. Yeah, that's definitely correct. So the light position location, light pos X, Y, and Z. For the view pos location, they even changed that. The lighting color, we was doing GFW get time by 2.0 f, 0.7 f, and 1.3 f. I feel like it's probably something to do with the time, but let's keep looking. Light color times by G of Vec3, 0.5 f, 0.2 f. The ambient color seems to be a-okay as well. Let's have a look at the lighting shader program. That's the problem right there, my bad. What I've done, as you can see for the material, with the material.ambient, material.diffuse, material.specular, material.shininess, whereas for this, we just did light.ambient, then diffuse and specular. Therefore, it wasn't properly applying the diffuse and the specular. Honestly, I just want to confirm that everything else is correct. Looks fine to me, so let me rerun it. Probably will be an error, probably come back. I'll fix it. Oh, no, that's looking exactly the way we want it. Just beautiful. Here you can see that sort of greeny emerald has more of a shine to it than, let's say, that material there. And what we're going to do is just move the light so we can see how it affects all of this. I remember this was a little too fast, so I'm going to put 0.5, 0.5. See, look at how cool that looks. That's definitely the best way of learning, is about doing something like this so you can actually see the effect of it. Okay, so that is it for this OpenGL, modern OpenGL tutorial on materials. If you have any questions, feel free to post them on our education platform, sonarlearning.co.uk. There will be a link in the description. Alongside that, there will be links to every single thing that we mentioned in here in terms of links. There will also be a link to the source code, which I did mention. If you like the video, please give it a thumbs up, hit that subscribe button, and leave us a comment. If you didn't, I'm sure you'll let us know in a nice and positive manner. And as usual, thank you for watching, and I hope you have a great day.